Well, good morning, good afternoon, and good evening to our friends around the globe. Welcome to this Progress webinar on the fastest way to build mobile apps with cloud data. Now, as developers and decision makers who are confronted with an ever-changing mobile landscape, you may not know which way your head is pointed when it comes to mobility. And really, that's okay. There's a lot of confusion and misdirection in the market today. However, we at Progress are here to provide some really clear and concise guidance for you today, building on our many years of experience in this space. So today, we want to focus on a handful of topics for you, and most importantly, provide you some clear next steps in your mobility journey. Now, before we start, I did want to mention that, yes, this webinar will be available on YouTube in the coming days. If you have any issues with audio or video, rest assured you'll be able to watch it in its entirety later on. And if you have any questions during the webinar itself, please ask away using the Q&A panel provided in GoToMeeting. I think it's right over there, if I'm pointing in the right direction. All right, so let's start with a blueprint of the next 45 minutes or so. Really a very brief intro to the concepts and technologies we will be covering today. And the first is Angular. Now, Google's Angular framework has proven to be the #1 JavaScript framework in the enterprise. Now, while it has competitors in React and Vue, Angular has really held its own and lends itself especially well to being used for both the web and, as we'll see today, mobile apps. Now, if you're not invested in Angular yet, you should know some of the primary benefits, such as the cross-platform nature. You can use Angular to build for desktop web, mobile web, progressive web apps, and native mobile apps. Performance. Apps built with Angular are optimized for today's JavaScript virtual machines on all devices. And productivity. Using Angular and the Angular CLI opens up a door to numerous tools and features like a robust templating system that will really make you and your developers as productive as they can be. Next up is NativeScript. Now, I alluded to the fact that you can use Angular for the web and also for mobile app development. And this is where NativeScript comes in. NativeScript is a free and open source JavaScript framework that works with Angular to allow you to create experiences on any device, iOS, Android, and web from one codebase. NativeScript is built by Progress, so you know you have a strong open source backing from a reliable industry veteran. Now, NativeScript shines in some key areas when it comes to native mobile app development. The first being performance. NativeScript apps are truly native. When you add a button element to your app, the NativeScript framework automatically transforms that into a native UI button on iOS and a native Android widget button on Android. This is all without you having to write a single line of Swift, Objective-C, or Java. Web skills. Apps written with NativeScript use JavaScript, TypeScript, Angular, or Vue.js. Apps are styled with CSS. And yes, this is the same CSS you've been using for years. And the markup is a friendly HTML-like XML syntax. Unlimited API access. NativeScript gives you access to the entire library of both iOS and Android device APIs without relying on plugins. And finally, code sharing. NativeScript isn't just about native mobile apps. You can also share code between a NativeScript app and a web app, giving you 3 platforms for the price of 1. We're going to touch on this again later. While we're on the topic of NativeScript, you should know that nativescripting.com has a wealth of Angular and NativeScript courses for you to check out. I highly recommend this resource if you're a video learner. You can find this course, NativeScript with Angular Pro, easily on the website at nativescripting.com. All right, next up is Kinvey. Now, virtually every app out there, I don't care if it's a web app or mobile app, needs a reliable and secure backend. Now, as a serverless cloud backend, Kinvey is quite literally the best backend to use with NativeScript and Angular. Now, Kinvey has some major advantages in a few key areas. The first being security and compliance. Kinvey is fully HIPAA, PCI, CSA, and FERPA compliant. Now, if you're not familiar with HIPAA, it's a set of incredibly stringent requirements to secure healthcare data. With Kinvey, your data is encrypted on the client while in transit and at rest in the cloud. Now, serverless capabilities. With cloud functions that just work, you can be up and running in no time and not worry about provisioning or scaling servers. Integration with cloud providers. Of course, this is a big part of today's webinar. how we can easily integrate with cloud providers like Salesforce. Now, Kinvey Rapid Data also connects to Microsoft SQL Server, SharePoint, SAP, and more. And finally, authentication integration. Kinvey Mobile Identity Connect makes it much easier for you to connect to your enterprise auth system and abstracts away all the nasty configuration that you normally have to do to authenticate your mobile users. So those are the big three today: Angular, NativeScript, and Kinvey. All three are great alone, but certainly better together. And now, before I introduce our speakers, there is one other concept that I touched on that I'd like to return to quickly. Now, this is the concept of web and mobile code sharing. Now, the reality today is that we are developing for multiple environments, multiple devices, different platforms, different screen sizes. And so if you look at the MVC pattern of app development, by leveraging Angular and NativeScript to create experiences across web, iOS, and Android, you can share both your models and controllers across all platforms. It's really only your view layer that has differences between the web and native mobile. So clearly you can save a ton of time reducing code you're writing by using our code sharing strategies that you'll see today. All right, let's introduce our speakers today. The first is a guy you've already heard speaking for a while. That's me. My name is Rob Lauer, and I run the Progress Mobility Developer Relations team. You can find me on Twitter at Rob Lauer if you want to connect later. Next is Ignacio Fuentes. Ignacio is a senior sales engineer here at Progress and is an expert on a variety of our tools and services like Kendo UI and Kinvey. Find Ignacio on Twitter at Ignacio A. Fuentes. And last but certainly not least is TJ Van Tol. TJ is a principal developer advocate here at Progress and today's NativeScript and code sharing expert. Connect with TJ at TJ Van Tol. Now, follow these guys now. Well, maybe not me. I don't even belong on the stage with these two. Before I hand the stage over to Ignacio, I'd be remiss if I didn't mention a conference we are putting on in Boston at the end of October. JS MobileConf is a two-day, two-track conference focused on JavaScript, mobility, and cutting-edge technologies. We have speakers from Microsoft, Google, Adobe. Some of us from Progress will be there. Loads of talks on everything from NativeScript to Angular to serverless, blockchain, AI, machine learning, and more. Check it out at jsmobileconf.com. And as an added bonus just for being part of this webinar, use the discount code CLOUDWEBINAR to get 30% off your JS MobileConf tickets. So take a look at jsmobileconf.com for a full list of speakers and sessions. We do expect it to sell out. All right, so today we're going to be presenting you a very real scenario with a very fictitious company, Acme. Acme already has a customer ticketing system in Salesforce, but they need a better interface for that data. They need a web app, and they need mobile apps for iOS and Android. The apps need to be fast so their end users can be productive, but they also need the development of said apps to be as quick as possible too. So they need to repurpose their existing dev team's web skills. So Ignacio and TJ are going to do just that. Build a web app and native mobile apps using Salesforce data from a single code base using the technologies I just described. Now with that, I'm going to pass the baton over to Ignacio. Take it away.
Thank you, Rob. Now, in order for us to get started building our web and mobile experiences, we will of course need a backend. For that, we will use the Kinvey platform. So Kinvey is a digital backend as a service. Let me provide a brief architectural overview of what Kinvey is. So once again, Kinvey is a digital backend as a service. It provides you with everything that you need on the backend side so that you can focus on creating your mobile, web, and desktop experiences. With Kinvey, you get a few building blocks that make this app development experience simpler. An example of this is our client SDKs. Most Kinvey features are exposed as RESTful endpoints, but making use of the client SDKs make interacting with those RESTful endpoints even simpler. The client SDKs provide you with an abstraction layer so that you don't have to learn all the intricacies about HTTP and HTTP headers. It also gives you authentication out of the box for your web and mobile apps. It gives you offline support, and it gives you encryption of the data. Now with the Kinvey platform, you also get Identity Connect. This allows you to have an out-of-the-box secure authentication mechanism. It also allows you to connect to pre-existing authentication servers like OAuth, LDAP, SAML, etc. You will also get ready-to-go push notifications, SMS, and email. Naturally, there will also be times where you need to do some kind of server-side data transformation or mashup. You want to produce your own custom endpoints, or you want to schedule jobs on the server side. This is all available to you as part of the Kinvey platform via the Flex service runtime that's included with it. As part of the Kinvey platform, you also get a data store and a file store. What this means is that with a few clicks, you'll get a database, and you'll get a database that is exposed as RESTful endpoints and is easily consumable from web and mobile applications via the client SDKs. You'll also get file storage for scenarios where your application might need uploading of files or downloading of files. This is enabled by the file storage feature. Another critical aspect of the Kinvey platform is the no-code rapid integration into pre-existing databases. So if you already have a SQL Server or a SharePoint or an SAP endpoint or RESTful endpoint that you want to interact with, Kinvey allows you to connect with them with no code. Now for other databases that might not be supported for the no-code rapid integration, there's a low-code integration with the Flex Services SDK. So with that, we can get started taking a look at Kinvey in action. Now, in order for us to create the Kinvey backend for our app, we need to go to console.kinvey.com. We will log in, and we can create an app. We will call this Acme Tickets. We will add it to our Acme organization, and we're taken to the dashboard of the application. You can see here some information about what the application has currently done. So we can see, of course, that we have 0 users, 0 API calls, 0 data storage, and 0 file storage. You can see we have some options for setting up authentication via the Identity tab. We can see that we have a Data tab. We can see where we can set up the business logic, the engagement, and the settings. Now, the quickest thing we can do right now is create a collection. Let's do that. We'll add a collection. Let's say we will call it Tickets Collection. And just by doing that, we actually now have a database. It's a database that's using a Kinvey data store. And we can configure a separate data service later. For now, let's import some data so that we have something to work with. We'll drag and drop a JSON file, hit import. As you can see right here, we now have some actual data. So what this means is, going back to what we were talking about before, we now have a database. This is a NoSQL database, and it's already exposed as a collection. In fact, we can go to the API console and take a look at what that collection looks like. So if you make an HTTP request to this endpoint, this tickets endpoint, we hit send, we now can see that the data is exposed as a simple JSON file. It's a JSON array that we can interact with. Now, we can also set up some authentication for this application. A quick way to do that is to add a user. Let's say we want to have an admin user as part of our application. Simply doing admin will do for this one. And that means that now the admin user could log in to the Kinvey backend with those credentials. But we could also connect it to an organizational authentication mechanism, for instance, Active Directory. Our organization is already set up with an Active Directory. So let's do organization single sign-on. And that's it. The application, the Kinvey backend is already provisioned to accept requests coming from an Active Directory authentication token. To see more of this, we can hit this settings, and we can see how the Active Directory was configured. Going back to the application, if we go to the tickets collection, we can, for instance, hit the settings tab again, and now for data source, we could configure a Salesforce service object. Now, we already seem to have access to a Salesforce service, but it doesn't have any service objects exposed. So we could do that. Let's go to the service object for the Salesforce connection. Let's hit Discover. And we can see here now we have under our Salesforce connection 362 different Salesforce objects that we can work with. For tickets, the Salesforce already exposes a case endpoint that we can work with. So let's find that. And here it is. We can call this case. And we can now choose which operations on that Salesforce connection we want to interact with. We'll just choose all of them. And we also have the option to field map. So it discovered 36 fields from Salesforce. Let's add them all just to see what we got. And we can start cleaning it up if we don't need all of them. Let's do that quickly. As we can see now, if we save that, we now have a service object that we can work with. So if I go back to my application, go back to my collection, use a data service, and now we have a service object here, and it's the case service object. Hit confirm. So now the same tickets collection is now bound to a Salesforce Acme data source. If we go back to the API console, hit the tickets again, we can now see a completely different response. In fact, this would correspond to what we have on our Salesforce environment. So at this point, we're exposing the Salesforce data in a much more consumable way, thanks to the power of Kinvey. This is particularly useful considering that Salesforce is traditionally complicated to interact with. With this in place, we can now get started creating an application that will interact with this Kinvey backend. Let's do that. Okay, so now we can get started creating an Angular application by using the Angular CLI. We will use the NativeScript schematics collection as part of the shared template. We'll be covering that in more detail later. So we will hit enter and a new application will be created. This will make use of the typical Angular folder structure with a couple of differences that are meant to cater for the shared project that allows us to work with web and mobile at the same time. We will wait for the CLI to finish creating the initial folder structure of our application. And we can just ng serve it to see what we have. At first, we have a regular Angular application with nothing really different. Now we know we will need to add the Kinvey SDK, and we also need to add the Bootstrap SDK, as we will be making use of the Bootstrap CSS for our styling. At this point, we can open up the application in Visual Studio Code. As we can see here, we have a regular folder structure, a typical folder structure for an Angular application. It's got a home component. We will drag and drop a couple of assets that we'll need, a font file and logo.png. Now at this point, we'll also need to create a few other components that are going to be required for our application. So we will need a logging component, we'll need a tickets component, we'll have a layout file that will help us for styling, we'll have a service layer and a couple of authentication guards. So we'll just do that with the Angular CLI, creates all those folders and files for us. We will wait for it to complete. And let's try now running the application again. We'll hit ng serve, and if we try running the application again, it will actually should be exactly the same. So let's open up the application. We can see we can run it in the browser, everything looks the same. This is good. Let's take a look at the routes file. Let's define the few routes that are going to be part of the application. There should be a root route, a login route, and a tickets route. The tickets route protected by the logged-in guard, and the login guard protected by the anon guard. So this means that if you want to enter the tickets component, you need to be logged in. Right now, this is not being enforced, so let's do that. If we try to implement the logged in guard, we'll need to determine whether the user is logged in or not. This should be covered by a service layer. The backend service layer should suffice for that. So let's implement a backend service layer. Right now, there will be a few methods in there. We'll cover them in more detail later. As you can see, the method that we do need is the isLoggedIn method, which essentially checks whether the Kinvey user exists. Now, we run the application again. We can see that the login route is what's being hit. So let's implement the login route. We'll add a few HTML elements to it, like a form and a button to log in, and we'll make use of Angular's reactive forms module for this. Let's add that module to our application. We'll import it. This will be part of the Angular forms module. And then we'll add it to our ng modules imports. So just by doing that, our form should now at least be functional. Let's try that again. And there it is. Now we can see that it doesn't have any kind of styling to it. So we can now apply a little bit of CSS to this form so that it will look a little bit nicer. And there it is. Now the login page, although it looks nicer now, doesn't actually work. As you can see here, there's a couple of errors in the console. The most logical error, of course, is that there's no form group. So we'll need to implement that in our login component, as well as, of course, the actual login functionality itself. So let's do that. So as you can see here, we now have a few methods that we can work with. There's the async login button, as well as the async login with mobile identity connect button. This gives the correct functionality that we need for the login page. As we can see now, we refresh the page, there's no more errors, and if we hit the login button, we are taken back again to the layout page. This is what we wanted. So this means that we now need to implement the layout page. Let's add some HTML to it. We're going to be making use of Bootstrap for this. As you can see here, we're adding a router outlet so that the tickets component will trickle down as part of the HTML. Now it doesn't actually let us log out, which is critical for the layout page. Let's implement the logout method on the layout component. We will do that. We can see it's also going to be making use of the service layer to do that. The logout method is implemented in the backend service. It's as simple as kinvey.user.logout. So now we can log out. Just to review the login and logout flow, let's test this. Let's enter the wrong credentials and see how it actually does not let us in. With the correct credentials, admin, we can continue logging in. We can also try logging in with company credentials via Mobile Identity Connect. And we're back in. If we see here, we have two methods, logging in and logging in with Mobile Identity Connect. Kinvey in the backend takes care of everything else. So now that we're able to log in and log out with regular credentials or with Active Directory credentials, we can implement the tickets page. So let's do that. We'll open up the tickets.html file, add a bit of HTML to it, again making use of Bootstrap. We'll make use of rows and columns, and we can see we have the right placeholders to add tickets and a little bit of statistics if we wanted to. Now to visualize the tickets, we will be making use of Kendo UI. Kendo UI for Angular in particular has very nice components that we can use in our Angular applications. We will be making use of the grid and the charts and the buttons. So let's add them. We will again make use of the Angular CLI to ng-add those Kendo for Angular components. We will wait for it to be done. Now what's nice about making use of the ng-add command is that it actually modifies our app.module for us. So as you can see, it will add the buttons module and the charts module and the grid module both as imports and as imports as part of the ng module. Let's try running the application again. And everything still continues to work. We can log in, we can log out. We haven't broken anything, which is good. So at this point, we can go into our tickets component. We can modify the component to make use of the backend service so that it will read tickets from the Salesforce API. So we can see here, we'll make use of the getTickets method, which is going to be using a cache collection from Kinvey. We will query the tickets, send it back to the component, and now we want to visualize that information as a Kendo UI grid. So let's add a grid here. You can see now we've added a grid with a few columns. We can see that we bind it to the tickets property as part of our component. And if we refresh the page, the grid is there with all of its columns. We also want to add a chart to visualize how many tickets have been responded and how many are working, how many are open, etc. So let's add a chart. We will add a pie chart. We will bind it to a pie data property in the component. We can bind the field value and the category field to category. And we can see this is a simple array with 3 properties on how many tickets are working, how many are open, and how many are closed. You can see now we have a chart right next to the grid. And one final thing that we can do now is change the status of the different tickets. Now for this, we're making use of Kendo as for the Kendo buttons, and we're relying on the backend service, the service layer of our application where Kinvey is being used to go and make a save operation via the Kinvey SDK. The save operation will have the new status of the ticket. Now if we go back to Salesforce, we take a look at any given ticket, we can see that it actually reflects exactly what we have on our application. If we see a ticket that's got a working status right now, let's change that working status to something else. We go back now to the Salesforce API, the Salesforce website, refresh the website, and we can see it now reflects the new value of the ticket. So Kinvey is interacting with Salesforce and the Angular application is interacting with Kinvey. Now this is where Kinvey shines. Kinvey allows the mobile developer and the web developer to interact with its SDKs in a way that is transparent and predictable. It doesn't matter whether the Kinvey collection is using Salesforce as its backing data, whether it's using SQL Server data sources, whether it's using some other RESTful APIs, or whether it's actually using the built-in Kinvey NoSQL database. It's all the same. The web developer only interacts with the client SDKs, and on the server side, Kinvey does all the heavy lifting. This is why we can see that we can change the status of the ticket in our regular Kendo grid, but it actually bubbles up all the way to the Salesforce environment. Hopefully this gives you a good idea of how to get started working with Kinvey on the backend side as well as on the front-end side with the Angular SDK. Now it's time to get started creating the mobile version of this application. And with that, take it away, TJ.
Hey everyone, this is TJ from the NativeScript team. So Ignacio showed you how to take data that lives in the cloud and easily connect to that data using Kinvey, and also how to quickly spin up a web app that uses that data. What I'm going to do is show you how you can extend that exact same application, same one Ignacio worked on, and add on a completely native iOS and Android app using NativeScript. First, just for a little bit of background, we at Progress have been working with the Angular team over the last handful of years to come up with a workflow that developers could use to build for web and mobile at the same time. And we actually just released the initial version of that workflow just last month. How this works is you have one project where all of your code lives, and you have separate commands for running your project on the web or in native apps. Ignacio showed how to use ngserve to build your project for the web, so I'll be covering the other commands and show how you can use that exact same project to build native iOS and native Android apps. Now, I do think this is one of those things that's just easier to see in action, so let's switch over to some code. Here, I've got the same Acme app up in Visual Studio Code, and we're going to dive into the folder structure you see here in a minute. But first, I just want to show you how to run this app on iOS or Android. So I'm going to drag my terminal over here, and this is the command that Ignacio used to build this Acme app. Now, if you're an Angular developer, you might recognize ng-new as just the way to start a brand new Angular app, but what you probably don't recognize is this bit about NativeScript schematics. Now, NativeScript schematics sounds like a fancy term, but really it's just an extension of the Angular CLI that tells Angular how to do NativeScripty things. And really, that's all you need to know. Don't worry too much about the semantic details here, and I'll include some links at the end of my talk in case you want to dive in and learn more. Because I'm using NativeScript schematics though, I can use the NativeScript CLI to run this Angular app on iOS or Android devices. TNS is short for Telerik NativeScript, and it's just the name of the command you use to perform NativeScript operations on your app. What NativeScript is doing at the moment is taking your code, your Angular app here, packaging it into a completely native iOS app, and deploying it to an iOS simulator because I passed this -- emulator flag. When it's done, which it actually just finished here, you'll see the app on this iOS simulator. You'll also see that this app doesn't exactly look like the app Ignacio was working on. To explain what's up and what's happening here, let's dig into the project's code a little bit. You might have noticed earlier that at certain points in this app, for example, let's look in this login folder that builds the starting login page of this app. There are certain files that use a .tns naming convention. You can see it here on the CSS and HTML files in this folder. This convention is a way of splitting your code, when necessary, into separate web and native implementations. For example, if you look at the file that does not use the TNS prefix, the login.component.html file, you'll see it has the web implementation of this app's login page. And in a web browser, this looks great. We saw it a few minutes ago. But in a native app built with NativeScript, because NativeScript uses native user interface controls, you can't use elements like divs or forms or inputs. These aren't controls that you can render in a completely native app. NativeScript instead provides a series of user interface controls that render iOS and Android components. And this is where the TNS naming convention comes in. Any file that contains this extension is used only for the NativeScript version of your app. For example, you see the Hello World label here because it appears in the .tns or the NativeScript version of this login component markup file. The power of this approach is you can design optimized user interfaces for each platform while still sharing a whole lot of code. To show that, I'm going to paste in a full implementation of this app's mobile UI. Now, if you've built NativeScript apps before, these components are going to look fairly familiar. If you're new to NativeScript, I'd encourage you to try NativeScript out at play.nativescript.org. This is the NativeScript playground. And specifically, this components section on the bottom left-hand side of the screen lets you drag components into your markup and see how they're rendered on your device. It's a really great way to start learning about NativeScript UI. Regardless, I don't want you to focus too much on the details of this login markup. What's cool about this workflow is that once you do have this UI defined, you can leverage all of the code that your web app used. For example, this was great for me. It made me look cool to my boss because I defined this mobile UI, and then when I actually went to code everything behind this, I already had the login code already done. Ignacio basically did all the work for me because I'm using the exact same backend service. In fact, it is literally verbatim and shared between the web and mobile implementations, which means I get a corporate sign-in with Active Directory here. This Mobile Identity Connect feature of Kinvey just works out of the box. And also this Kinvey login with my super secure credentials here also works without me having to do any work at all on the back end. In general, you have a whole ton of power with this setup. You could, if you really wanted to, build completely identical versions of your web and your mobile apps. Or you could show slightly different UX depending on the platform. For example, you might recall that the web version of this app showed a list of tickets, and then it also had a little chart with some data about the tickets on the right-hand side of the screen. But when we were creating the mobile app, we said, well, space is a little more limited here, so we moved the stats to their own page, utilizing NativeScript's rich charting libraries. But again, this was fairly simple to build because when I built out this page, I was again able to use the exact same backend service, so I didn't have to worry about how I'd access this data or care that this is coming from Salesforce. I basically just got to call a method that Ignacio already wrote for me and build a pretty nice looking chart on top of that. And really, we're just getting started because we now have native iOS and Android applications. So you can do a lot of stuff that's simply not possible on the web. Now for Acme, this is actually one of the main reasons they wanted to use this workflow. The app you see here is designed for technicians. These technicians head out into the field, they investigate problems that appear on this tickets page, and when they're done, they close out these tickets. The problem is the technicians often work in places where internet connectivity is spotty or non-existent. And Acme really wanted an app where the technicians could change the ticket status while offline and ensure that those changes make it to the server when the technician regains access. Now, normally, if you've tried to implement this before, you know that this can be a fairly complex problem. But between NativeScript's rich mobile APIs and Kinvey's powerful backend functionality, the implementation for this Acme app is actually quite simple. So what we did to make this app work is add a bit of code to our app component. Now, if you're not familiar with Angular, all you really need to know is your app component is basically the entry point to your application. It's some of the first code that runs. And we created a .tns version of this file because this is code that we want to write for, or that we want to run for the mobile app only. What we're going to do is use NativeScript's built-in connectivity module. Now, NativeScript has a bunch of modules for doing common mobile-y things. So connectivity, obviously a common thing you might want to do in a lot of apps. What we're going to do is use the connectivity module to monitor the user's connection. And whatever it changes, NativeScript gives us this handy little callback that tells us what the new connection type is. So if the new connection becomes either Wi-Fi or mobile, that basically means that the user regained access to a network. So this is provided by NativeScript, this module to tap into some iOS and Android functionality for monitoring connection type. The next part is the Kinvey piece of the puzzle. Kinvey automatically keeps track of which records or which updates have not been synced to the server. So here I'm getting the number of items that have yet to be synced. And if there are items that still need to be synced, I'm going to show the user a little notification. This is again using another built-in NativeScript module for showing little notifications. You'll see this in a second. And then using a feature of the Kinvey SDK to just push those changes that are waiting, that are pending because of network issues, and go ahead and push those changes up to the server. Let's look what this looks like in action. Now, I have been showing this app on iOS, but since NativeScript is a cross-platform framework, I'm going to switch over and show this app on an Android emulator, which I set up earlier. And what I'm going to do is suppose I'm a technician. I'm out in the field. I'm going to log in. I see that there's an electrical wiring issue here. So I head out to look, and what do you know, that electrical wiring issue actually took out the facility's Wi-Fi. So I'm going to take my device here and I'm going to go offline. A few minutes later, I fix the problem. So as the technician, I come in and I'm going to close the ticket because I'm going to say this is all set, all ready to go. But of course, I'm offline. So this change is never going to make it to the server. And actually, if I bring over the web app here and I refresh this, you'll see that the status of this ticket has not changed. It still shows as a new ticket, a new issue. But because of this code I wrote earlier, if I take my device and I go back online, so I go out of airplane mode, you'll see I hit this notification here because I'm monitoring the network connection. The connection changed to a Wi-Fi connection. I had a pending item because Kinvey was keeping track of this for me. I showed the user the notification you saw here, and then I push that change to the backend. Meaning if I bring up my web app here and I note the current status of this and just refresh my data, I can see the ticket has now been closed. This is the real power of NativeScript in Kinvey. I now have native iOS and Android apps that can share code with my web app and still have the potential to tap into rich functionality, such as the offline data sync that you saw just here. And remember, the data we're working with is in Salesforce, which I personally think is even more impressive. If you've ever tried to work with any of Salesforce's APIs, you're probably familiar with how difficult of a task this relatively simple thing I just showed would be to pull off. But there's one last thing I want to show you. With NativeScript, because you're working with these native APIs, there's really no limit to what you can do. Meaning, if there's an API that iOS and Android have, you can absolutely use them in your apps. So Acme's research division has been experimenting a bit. What they want to do is allow technicians to see equipment they'll be working on before they arrive on the site. Maybe they need to bring certain tools, manuals, or whatnot. So they've been working on the ability for technicians to view that equipment in augmented reality using some of the latest and greatest APIs available on iOS and Android devices. Now, because AR requires a device's camera, I can't show you this example in the iOS simulator, so I'm going to switch over to my iOS device, which I'm mirroring over here. And what I'm going to do is I'm going to view this ticket for the generator and click the View Equipment button. So AR requires a device's camera, so I'm getting prompted for permissions. And then I'm going to break the fourth wall of webinar recording software here and show you the office I'm working on. Now, this is using ARKit, which, if you're not familiar, basically works by having you detect a surface or a plane. And you can see I'm showing the plane with this sort of transparent rectangle that's appearing on my floor here. And for there, I'm coded it so I can just drop the equipment right there. So this is the generator that is having those equipment issues. My wife is totally going to love it when I show her the new generator I got for this office. But I'm showing you this example for a few reasons. And it's not necessarily because I think you're going to need augmented reality for the next line of business app that you're going to write. I show it because I think AR is really the best way of showing that there are no limits to what you can build using NativeScript. You have a native iOS or Android app, and you might not need AR, but there's potentially a lot of native functionality that you might need for your apps and for your businesses. The best way to discover what's out there is to head to market.nativescript.org, which is where we list the various plugins, templates, and some code samples you can find for NativeScript apps. In the plugin section, for example, you could find the AR plugin that I'm using to create this example. Maybe your app needs Bluetooth connectivity. Maybe it needs to work with certain kinds of beacons. Those are available as well. Maybe you need some sort of Facebook integration or authentication for your apps. There's really a ton there. In fact, I think we're almost to 900 plugins out there. So if you think there's some native functionality you might need or might want to build into your upcoming apps, head to market.nativescript.org and look around and see what's out there. And really, the big picture here is that with Kinvey and NativeScript, you have a whole ton of power when it comes to app development. Kinvey makes it trivial to connect to cloud data like Salesforce. You saw with this very simple backend service how we were able to immediately query and use Salesforce data and immediately start leveraging that data in our apps. And with NativeScript, you have the ability to build for multiple platforms. So you can use one code base to build for Android, to build for iOS, and to build for the web, and take advantage of the best of what all of these platforms have to offer, all from building with one single code base. Hopefully you found this demonstration interesting. If you're curious to learn more about the code sharing portion of this, I talked earlier about how ng-new worked and how all of these pieces fit together. If you head to the NativeScript documentation, which is at docs.nativescript.org, there's a link in the bottom left corner here specifically about code sharing. So it'll walk you through the NativeScript schematic stuff we talked about earlier, structuring projects and those sorts of things, and how to best leverage these technologies. So if you're interested in code sharing and building multiple apps at the same time, like I showed, check this out. And with that, I'm going to turn things back over to Rob. Rob, you want to take it from here?
Awesome, guys. Thank you, Ignacio, and thank you, TJ. As a brief recap here, I hope you've seen how powerful this Angular NativeScript Kinvey ecosystem can be for building experiences across web and mobile using those skills that your developers already have. Now remember, with Angular, you get the benefit of building cross-platform apps with the performance and productivity you need. With NativeScript, you're getting blazing fast performance out of your mobile apps, reusing code and reusing skills to create truly native apps on iOS and Android. And with Kinvey, you're getting a fully compliant and secure serverless cloud backend right out of the box. Now, where do you go next? Well, I've got some ideas for you. The first is read about the modern mobility landscape with our free ebook. You can find this valuable resource at tinyurl.com/progress-ebook. Now, are you curious about NativeScript at all? Well, the easiest way to get started with NativeScript development is with our tutorials on the NativeScript Playground. It's available at play.nativescript.org. And everyone should sign up for a free Kinvey account at tinyurl.com/kinvey-console. You'll get up and running in no time with Kinvey and take advantage of all the services we went over today. And finally, don't forget those NativeScript video courses available at nativescripting.com. Now, I'll leave this slide up here just for a moment, just to make sure you have time to take notes. Good? All right, finally, don't forget to visit jsmobileconf.com to learn more about our conference and meet some of the top NativeScript, Kinvey, and Angular experts face-to-face. So thank you all for attending. I know your time is precious, so we appreciate the opportunity to share some of these ideas with you. Have a great rest of your day.